Hello, I'm glad to have the opportunity to today present how we take micro-abrasive water jet to the next level by using 5-axis control. I am Christian Neumertz. I am the CTO and founder of Finepart Sweden. I've been working with water jet technology for 30 years, and it's a thrill for me to see how the process has evolved over the years and that we are now cutting parts with high precision and very high quality. As most of you already know, the water jet process has many benefits. Most of all, it's a non-thermal process, which means that we will not have any thermal effects on the material, no recast layers, no heat affected zones. Other than that, it's also a process that is based on particle erosion. And since the particle erosion can use many different material removal mechanisms, the process has the ability to adapt to any type of material. So, what is specific for micro-abrasive water jet technology? Well, the micro-abrasive water jet technology, that gives us the capability of cutting very small parts. We have jet sizes going down to 0.2 millimeters, so we can cut features down to 0.1 millimeter in radius. We can cut through different materials. We can even cut multiple layers of materials of different types that are stacked on top of each other. Since the process has a very low cutting force, we can cut very delicate, thin sections. We can cut down to approximately 100 microns in cut width. The process gives a very high tolerances. We can achieve down to approximately plus minus 10 microns in tolerances, and we can achieve excellent surface finish below 1 micrometer in RA value. And we have the non-thermal cutting advantage. We do not need any finishing process to remove recast layers or remove heat affected zones, so we will have the same material properties from the core and out to the surface. So what is the challenge with abrasive water jet technology? Well, one challenge is that it's a dynamic tool. It's not a geometrically defined tool. Depending on the cutting speed, we will have the jet being deflected slightly by the materials. The faster we go, we will have more of a jet lag with the bottom of the cut lagging behind the top of the cut. Also in the taper and the width of the cut is depending on the cutting speed. So if we go fast, we will have a taper where the width of the cut at the top is wider than the cut at the bottom. If we go down in cutting speed, we will reduce the taper, and at some instance we will have parallel walls of both sides of the cut. And we will even get negative taper. To get a really good part in micro-abrasive water jet cutting, we want to go to a speed where we have no taper. If we have a 3-axis machine, we have to reduce the speed significantly to reach this part. What if we could go this fast? If we could have a database saying how much taper we have at a specific speed, we could compensate for this taper. This would mean that we would lose a little bit of the roughness quality, but still we would be able to maintain tolerances. When we build 5-axis control, we can do that in different manners. One way to do it is to tilt the jet with one axis and to tilt the part with another axis. Another way is to bring 2 axes on the jet and to tilt it in 2 directions. For this test, we have been using the manipulation system that tilts the jet in both axes. We have made a case where we have a medical device part in titanium. This part has a tolerance requirement of plus minus 10 microns. It's made from 3 millimeter thick titanium. The taper of the cut must be within tolerance as well. And we need to have an RA value below or equal to 1.6 microns. So, when we were trying this, we have been making test cuts. We tried to cut with the 3-axis setup, And to get straight walls with no taper, we had to reduce the speed to approximately 30 millimeters per minute. And it was still difficult to get rid of all of the taper for this part. So what we do now is that we want to compensate the taper by using the 5-axis control. And we went to cut with quality number 4 with the speed of approximately 80 millimeters per minute. And we were actually able to reduce the taper to 0 and still maintain the 1.6 micron in RA value. Of course, when we make a machine with a 5-axis control and 5-axis mechanics, that would add cost to the machine. We will also have a running cost for the part, and the running cost will add up to an accumulated cost for a series of number of parts over time. But if we use the 5-axis machine, that would add to the investment cost, that would be higher. So the 5-axis machine would cost more, but we cut quicker, so we will have less running cost for each part. So we actually reduce the running cost by 60%. And this means that when we are cutting a number of parts, the accumulated running costs increase more slowly. And for this specific part, we will have a payoff time that is approximately of 1 year. To sum this up, we can see that the 5-axis manipulation has the potential to bring substantial benefits for productivity and economy in microabrasive waterjet cutting. In this current case, it has shown that taper can be eliminated and part can be cut within tolerance. We see that we get typically 15% higher surface roughness. Here it's approximately difference of 0.2 microns. And we have the potential for increase in productivity of 134%. We cut more than twice the cutting speed, which gives us the opportunity to get a payoff time in the range of 1 year, typically. So with this, I thank you very much for your attention, and I am available for your questions either by email or at the live questions and answering session after this presentation is finished. Thank you.